Welcome back to the deep dive. Today, we're jumping into something that's, well, becoming more and more central: managing AI systems.
hmm
It's really complex, isn't it? It's not just about the flashy creation part. We're talking about the whole journey, understanding and governing these things
Well,
properly,
from the very beginning, that initial idea.
all the way through to when they're eventually retired. And AI, it's just different from regular software. It has these unique challenges that pop up constantly.
It really does.
So for this deep dive, we're leaning on some solid material. We're looking at key bits from the ISAC Advanced in AI Audit Official Review Manual.
Yeah, it's a pretty comprehensive guide, really useful for anyone involved in AI, especially if you're looking at it from an audit risk or, governance perspective.
Hmm.
Helps you get a solid grip.
Definitely. Now, the manual's big, but we're zeroing in. We're focusing on Chapter 2, which is all about AI
And
operations.
specifically, we're tackling Part B, AI solution development methodologies and life cycle. This part is, well, it's crucial because it lays out the entire path an AI solution takes. And maybe even more importantly, the core principles you absolutely have to weave in right from the get-go.
So think of us as your guides. We'll walk you through these concepts section by section, just like the manual does. And understanding this life cycle, these design principles, it's not just theory.
No, absolutely not.
It's fundamental if you need to manage, interact with, or critically audit these AI solutions. It's how you spot the risks, understand what the system can really do, its
And
limits.
ultimately make sure it's used responsibly, securely.
Exactly. You need that lineage, that history to see the potential weak points.
You really do. It shows you where those key control points and oversight moments are.
Okay, let's get into it then. Unpack this journey. We're starting with Section 2.8, the AI Solution Development Lifecycle, the AI SDLC.
Right. So the AI SDLC, conceptually, yeah, it's similar to the traditional SDLC from software engineering that many people know.
Yeah.
It's structured, a sequence of
Like
phases.
roadmap, basically.
Kind of, yeah. But here's the key difference. AI brings in complexities that are just fundamentally different from standard software.
How so?
Well, you're dealing with data that changes, models that learn and evolve on their own, almost. And the outcomes, they can be probabilistic, not just a clear yes, no, or this or that. It's fuzzier.
Ah, okay. Less predictable in some ways.
Exactly. So the AI SDLC covers everything: the initial concept, creation, implementation, running it day to day, and eventually turning it off for good, decommissioning.
And the manual gives us specific stages for this life cycle.
It does 6 key stages. Understanding these is pretty much the backbone of grasping the whole AI development process.
Okay, what are they?
First, plan and design. Second, build or adapt models. Third, test, evaluate, and validate.
Okay.
Fourth, make available for use or deploy. Fifth, operate and monitor.
Right.
And finally, sixth, retire or decommission.
Plan, build, test, deploy, operate, retire. Makes logical sense, that flow.
It follows a natural progression.
But like you said, the devil's in the details, right? The AI specifics within each stage.
That's where the nuances really lie.
Okay, let's dig into stage 1 then, plan and design. Why is this starting point so foundational for AI?
Well, you could argue it's the most important stage. Because any mistakes, any oversights here, they don't just stay here, they ripple through the whole thing.
Right.
And they get exponentially harder, more costly to fix down the line. This is where the whole idea for the AI system is really defined. What's it supposed to do? Why do we even need it? How will we know if it's working, if it's successful?
So it's about nailing down the why and the what.
Precisely. And articulating the problem you're trying to solve with AI. Sounds basic, but it needs real focus.
It's not just finding a cool AI tool and looking for a problem to throw it at.
Definitely not. Or it shouldn't be. The really critical activities here: define the concept clearly. What's the scope? What are the boundaries? Outline specific, measurable goals. Set up success metrics before you build anything.
How will you actually judge if it worked?
Exactly.
Yeah.
Then gather detailed requirements. What data do you need? What kind of performance are you expecting? What about response times, or how much it needs to handle? Any regulations? What technical environment does it live in?
Lots to consider.
Yeah, and sometimes building a quick prototype, a small-scale version, can really help here. Validate the idea, get some early feedback.
And this planning phase, that's also where you have to start thinking about risks, right? Like
Yep.
right at the beginning.
Absolutely critical. And not just technical risks, like
Yeah.
can we build it?
Yeah.
You have to confront the ethical issues up front.
Such as?
Well, could this AI cause ethical problems? Is there a risk of bias creeping in, either from the data we pick or the algorithm itself? What about accountability? If the AI messes up, who's responsible?
Tricky questions.
They are. And is the AI really solving a genuine business need, or is it just tech for tech's sake? Talking to stakeholders is vital here.
Everyone who might be affected by it.
Yeah. Users, operators, customers, maybe even the public. They give you insights, tell you about constraints, maybe warn you about unintended consequences developers might totally miss.
So getting that buy-in and understanding early on.
It ensures the problem you think you're solving and the AI solution you're proposing actually line up with what the business needs and, just as importantly, its values. This whole planning piece, it's the blueprint. It guides everything else.
That makes a lot of sense. Especially with AI's potential impact, getting that foresight feels crucial. Okay, so planning's done. We move to stage 2. Build or adapt models. This sounds like where the core AI work happens.
It is. This is the real technical engine room.
Yeah.
You're either creating a new model, a new algorithm from scratch, or maybe adapting one that already exists.
Yeah.
Then you calibrate it, you train it.
And data is king here, presumably.
Absolutely massive. You're collecting the data, cleaning it, transforming it, getting it ready for the model. And this data, it's not just input. It's literally the stuff that shapes the AI's brain, its capabilities.
Turning raw stuff into learned patterns.
That's the goal, turning it into actionable insights the model can actually use.
What are the big risks that tend to show up most during this build phase?
Oh, there's several significant ones. One is just, well, implementing the model incorrectly, bugs in the code, wrong configuration, leading to it not working right or maybe not securely.
Okay, standard software bugs, kind of.
Sort of, but then you get into the AI-specific stuff. A huge one is the lack of explainability or interpretability.
A black box problem.
Exactly. Especially with complex models like deep learning. It can be incredibly hard, sometimes maybe impossible, to really understand why the model made a specific prediction or decision.
And that's a risk because...
Because if you can't explain it, how can you trust it? How can you be accountable for it? How do you meet regulatory demands for transparency? It's a major hurdle in many situations.
I see.
Bias.
We touched on it in planning, but this is where it can really get baked in.
Through the training data itself, if it reflects historical biases, the model learns them. Or through how you select features, the variables you tell the model to pay attention to. Even the model architecture itself might inadvertently reinforce biases.
Wow. So bias can creep in multiple ways.
It really can. It's a pervasive risk in this stage.
Those risks sound pretty serious. How do you actually navigate them when you're building the model?
Well, it starts with picking the right tool for the job, selecting an appropriate model or algorithm for the specific problem and the data you have. Then you really need to understand its parameters, often called hyperparameters.
Hyperparameters?
Yeah, these aren't the things the model learns from data, like its internal weights. These are settings you configure before training starts. They control how the model learns.
Like knobs and dials for the learning process?
Kind of.
Yeah.
Things like the learning rate, how quickly it adjusts, the number of layers in a neural network, penalty terms and regressions. Understanding how tweaking these affects training and performance is key. And then it's iterative. It's a cycle. You train the model with your data. Then you interpret the results. Does it work well on data it's never seen before?
Generalization.
Right. Based on that feedback, you recalibrate those hyperparameters. Maybe you adjust the data prep. Maybe you even tweak the model's structure. Train, evaluate, adjust, retrain, over and over.
Until you get something that performs well.
That's the idea. Achieving a well-performing, reliable model.
You mentioned interpreting outcomes earlier, that explainability piece. Why is that so important, especially if some models are inherently hard to understand?
It's just vital for trust and for validation and for responsible use. Think about it. If an AI is making critical decisions, loan applications, medical diagnoses, very high stakes. Users, operators, auditors, they need competence in the outputs. Understanding how the AI got there, even if it's not a perfect step-by-step explanation, provides that confidence.
It lets people check its reasoning.
Exactly. It lets experts validate if the model's thinking makes sense, spot potential errors or biases, and crucially, know when not to trust an output. This isn't just a nice-to-have anymore.
It's becoming a requirement.
In many areas, yes.
Okay.
It enables that essential human oversight and makes sure the AI is used safely and appropriately.
That makes total sense. Just trusting a black box feels inherently dangerous. Now, the source material also mentions human in the loop, HITL here. How does that fit into the build stage?
HITL.
Yeah.
Yeah, it's often essential, especially when you're building AI for tasks where mistakes are costly or where, frankly, human judgment and nuance are still irreplaceable.
So keeping people involved?
Exactly. designed the process so human oversight is actually built into the workflow. During the build phase, this could mean humans checking data labels are correct.
Quality control for the training data.
Right. Or correcting the model's outputs during testing. Providing feedback on how it handles weird edge cases. It's not just about boosting performance, though it helps with that.
What else is it for?
It's critical for achieving better accuracy, yes, but also robustness, making the model less brittle and overall security. Humans can spot things. AI misses, catch bias, guide the AI in complex situations.
And does having humans involved also help with transparency and accountability later on?
Definitely. If you automatically log when and where human oversight was applied during development and later during operation.
You get an audit trail.
Precisely. If questions come up later about why a model did something, you can trace it back. See the data, the model version, see where a human stepped in. It massively boosts transparency and accountability.
Okay, so we've planned it meticulously, we've built and trained the model, maybe with human help. Before it goes out into the world, though, it needs serious testing. Stage 3, test, evaluate, and validate.
This is the make-or-break validation step.
Yeah.
Does it actually work as intended? Does it meet those requirements we set way back in the planning stage?
The proof is in the pudding.
Essentially, yes. It's not just about whether the code runs without crashing. The intelligence part has to function correctly, reliably, in the situation it's designed for.
And testing AI, it's different from testing regular software, isn't it? Because it's not always deterministic.
It is different. The testing needs to be really comprehensive and specifically tailored to AI's nature. You have to test against those performance specs you defined.
Like accuracy targets.
Accuracy scores, acceptable error rates, how it handles load, things like that. You also need to verify it's actually meeting its purpose. Is it solving the real business problem we identified?
And the level of testing depends on the risk?
Absolutely.
Yeah.
The testing has to be robust relative to the business impact. And AI recommending songs, maybe less rigorous testing than one involved in, say, autonomous driving or medical diagnosis.
Makes sense. The potential harm dictates the level of assurance needed.
Exactly.
The source mentions specific testing techniques for AI. Can you walk us through some key ones?
Yeah, the manual highlights several that are really vital for properly evaluating AI models.
Okay.
First, just basic verification and testing. Does the model perform according to its design specs? Does the algorithm run correctly? Does it give outputs in the right format? Foundational stuff.
Got it.
Then there's benchmarking. This is comparing your AI's performance against something else.
Like what?
Could be older versions of the model, competing AI solutions, maybe established baselines like how humans perform the same task, or even simple statistical methods. It tells you if your fancy AI is actually better.
Provides context for the performance number.
Right. Then stress testing. And this is really important for understanding how the model copes under pressure or with weird inputs.
Pushing its buttons.
Kind of.
Yeah.
Feeding it extreme data, edge cases, stuff outside its normal training experience. Scenarios designed to break it, basically. Helps find failure points before they happen in the real world.
Okay, stress testing. What else?
Comparative analysis. Similar to benchmarking, but maybe more focused on comparing against a specific predefined baseline performance level. Quantifies the value add, and crucially, bias and fairness testing.
We keep coming back to bias.
Because it's so critical. This means systematically checking the model's outputs across different groups. If it's dealing with people data, are the outcomes fair across different demographics?
How do you test that?
You might look at error rates, like false positives or false negatives across different groups. Are they roughly equal? Or are predictions systematically worse for one group? The goal is equitable outcomes, ensuring the AI isn't discriminatory.
That sounds complex, but absolutely necessary.
It is complex, but yeah, non-negotiable for trustworthy AI. It's not just about being accurate anymore. It has to be fair, too.
So rigorous testing across all these areas is essential before unleashing the AI.
Absolutely. You need that confidence before it goes live.
All right, let's say it passes muster. Testing and validation look good. We move to stage 4. Make available for use or deploy. Showtime.
This is the big transition, moving from the controlled development sandbox into the real operational world.
Putting it into production.
Exactly. Releasing it for actual use. Could be internal, integrated into business workflows, or external facing customers or the public.
And what's involved here besides just, flipping a switch?
Oh, there's significant planning needed.
Yeah.
You need clear release management plans. How exactly will it be deployed? When? Who needs to be involved? IT, operations, the business side. Coordination is key.
And what if something goes wrong right after launch?
That's where rollback plans are critical. You absolutely need a predefined way to quickly revert back to a stable state, a previous version, if unexpected issues pop up in production. Minimize the damage,
A safety net.
a vital one. Then there's the technical stuff. Installation, configuration in the live environment, making sure it plays nice with everything else. And crucially, training and awareness.
For the people who will actually use or interact with it.
Yes.
Yeah.
End users, operators who monitor it, support teams, they all need to understand what it does, its limitations, how to use it safely and effectively. Plus, clear notification processes so everyone knows it's live.
So it's really about preparing the whole ecosystem, tech, people, processes.
That's a good way to put it, preparing the ecosystem for the AI's arrival.
Okay, AI deployed successfully. Now comes the long haul. Stage 5, operate and monitor.
This is where the AI is actively doing its job day in, day out, but it needs constant supervision.
Why constant? Doesn't it just run once it's built?
Not quite like traditional software. AI models, especially machine learning models, can degrade over time. Their performance can drift.
Degrade. How?
The world changes. The real-world data the AI sees in production can start to look different from the data it was trained on. This is called data drift. Or the underlying relationships in the data might change. That's concept drift.
So the patterns it learned aren't valid anymore.
Exactly. Customer behavior changes, market conditions shift, new factors emerge. The model's learned patterns become outdated. This leads to model drift or model decay. Its performance starts to slip.
Okay, so that's why monitoring is so critical.
Absolutely vital. You need systems constantly tracking its key performance metrics, accuracy, error rates, maybe specific business KPIs it influences, almost in real time.
Watching for signs of trouble.
Right. If those metrics start to dip, it's a red flag. The model might need retraining with fresh data, maybe tweaking, or potentially even replacing entirely.
So you can't just launch it and forget it. You have to keep checking if it's still smart enough for the current reality.
Precisely. Continuous monitoring is essential to make sure the AI stays effective, reliable, safe, and fair throughout its working life. And you monitor not just performance, but also things like data quality coming in.
And humans are still involved here, that HITL concept.
Often, yes. Human oversight in the live environment is still really valuable. People monitoring outputs can spot subtle issues, weird anomalies, or emerging biases that automated systems might miss. They provide crucial feedback for maintenance.
It definitely sounds like operating AI is more dynamic, more maintenance-heavy than many older systems.
It absolutely can be. It needs ongoing attention monitoring, feeding it new data, retraining to keep delivering value in a changing world.
And then, inevitably, everything reaches an end. Stage 6, retire or decommission.
The final chapter, taking the AI solution formally out of service.
Why would you do that?
Maybe it's been replaced by a newer, better model. Maybe the business need it filled just isn't there anymore. Or maybe its performance has degraded too much, and it's just not worth the effort to keep fixing it.
Is turning off an AI different from retiring, say, an old server?
The basic idea needing a formal controlled process is similar, but AI has specific wrinkles, mainly around the data it used and the model itself.
Like what?
Decommissioning needs steps to remove it securely and compliantly. This means safely migrating any useful data elsewhere, securely archiving records if needed for regulations or history, and critically, ensuring no sensitive data or valuable intellectual property tied up in the model or its training data gets left exposed or accessible once it's shut down.
Cleaning up properly.
Exactly. Whereas careful planning for a clean exit, updating documentation, telling stakeholders it's gone, it's a structured shutdown, not just pulling the plug.
Okay, that covers the whole life cycle then. Plan, build, test, deploy, operate, and retire. It's a full journey, definitely with those unique AI twists we talked about.
It really is a distinct process, and understanding these stages is so important. But there's something else the manual stresses, something that sits above all these stages.
Which is?
The principles of privacy and security by design, section 2.9.
Ah, right. So this isn't just one stage, it's an overarching philosophy.
Exactly. By design means you don't treat privacy and security like optional extras you add on later if you have time.
Not just a checkbox exercise at the end.
No way.
Yeah.
It means you proactively, intentionally build these considerations into the system's core architecture, into the processes, the data handling, right from the very beginning, back in plan and design.
Making them fundamental requirements from day one.
Precisely. They shape the system throughout its entire life.
The source mentions 7 foundational principles for privacy by design. How do those specifically apply when we're talking about AI?
They map really well, actually. They're great guidelines for responsible AI.
Okay, let's hear them.
First, proactive, not reactive. Preventative, not remedial. For AI, this means thinking ahead. Anticipate privacy risks before they happen.
Like designing data collection to minimize sensitive info from the start.
Exactly. Or choosing model architectures that inherently need less sensitive data, if possible. Don't wait for a data breach or a complaint to fix things. Prevent them.
Makes sense. What's next?
Second, privacy as the default setting. This means the system should automatically protect personal data at the highest level without the user having to do anything.
Opt out versus opt in.
Kind of. The default should be maximum privacy, minimize data, anonymize where possible. Users shouldn't have to dig through settings to protect themselves. Protection should be automatic.
Okay. Third.
Privacy embedded into design. Privacy isn't a separate layer. It's part of the core engineering. Built into the architecture, the code, the infrastructure, even the business processes around the AI.
Like privacy filters and data pipelines?
Yeah, or choosing models with privacy implications in mind. Making access controls fundamental, not an add-on.
Got it. Fourth.
Full functionality, positive sum, not zero sum. This challenges that old idea that you have to trade privacy for features.
The privacy versus utility trade-off.
Right. This says no, you can and should design AI systems that achieve their goals while also fully respecting and even enhancing privacy. It needs creative thinking, finding win-win solutions.
Ambitious but important.
Fifth, end-to-end security full lifecycle protection. Hugely critical for AI.
Yeah.
Robust security measures throughout the entire lifecycle,
From data collection.
all the way to retirement. Securing training data, operational data, protecting the model itself from being stolen or tampered with, securing the platform it runs on, ensuring secure decommissioning. Security everywhere, always.
Sixth principle.
Visibility and transparency, keep it open. Users need to understand how their data is being used by the AI. Now, fully explaining a complex model might be hard.
The black box again.
Right. But the processes, the policies around data use and AI behavior, those should be transparent. Clear notices, clear explanations of what data goes in, what the AI is used for, making it auditable where possible.
Building understanding, even if not perfect clarity on the internals.
Exactly. And finally, seventh, respect for user privacy. Keep it user-centric. Put the individual first.
Oh.
Give people clear notice. Get meaningful consent when needed. Offer controls over their data if feasible. Build AI systems that are accountable to the people they affect, respecting their choices about their information.
These principles definitely feel like a shift towards proactive, integrated thinking about privacy. How does security by design fit alongside this?
It works on the same core idea, applying secure development practices, integrating security controls right from the start.
Like threat modeling early?
Yes, threat modeling in the design phase. Using secure coding practices, maybe one specific to AI frameworks, and building in defense in depth.
Multiple layers of security.
Right, so if one control fails, others are still there. It's about intentionally building resilience against threats throughout the AI's development and operation.
And does thinking about security by design help defend against those weird AI-specific attacks we hear about, like prompt injection or data poisoning?
Absolutely. While the manual might detail those attacks later, security by design is your foundational defense. If you've built secure data pipelines from the start.
Less chance for poisoning.
Right. If you
Yep.
validate inputs rigorously.
Harder to inject malicious prompts.
Exactly.
Mm-hmm.
If you monitor model integrity, implement strong access controls, you inherently build defenses against these vulnerabilities. It makes the system much tougher to crack than if security was just patched on later.
Building the fortress walls strong from the beginning.
That's a good analogy, not just fixing holes after the attack.
So wrapping this section up, why are these principles, privacy and security by design, so incredibly important for AI? Maybe even more so than for older tech.
Well, the stakes are often higher and the risks are different.
Mm-hmm.
AI often needs huge amounts of data, and that data can be very sensitive, very personal.
Mm-hmm.
The potential for bias we talked about. You can have massive real-world impacts, jobs, loans, healthcare, discrimination baked into the code.
Serious consequences.
Very.
Mm.
Then there's public trust. People need to trust these systems will handle their data properly, operate securely, treat them fairly. If that trust erodes,
Adoption stalls, benefits aren't realized.
exactly, breaches or bias incidents can kill trust fast. And finally, regulations.
GDPR, CCPA, new AI laws coming.
They increasingly mandate proactive privacy and security. It's often not just best practice anymore, it's the law. Building it in by design is really the only effective way to meet these demands and ensure AI is used responsibly.
It really hammers home that you can't just sprinkle privacy and security on top at the end with AI. It has to be baked in.
Absolutely. They're non-negotiable foundations if you want AI systems that are reliable, safe, and that people can actually trust.
This has been incredibly helpful, really mapping out that entire AI journey from concept to decommission and stressing how vital embedding privacy and security is at every step.
Yeah, understanding this life cycle and these by design principles from the AISCA manual, it gives you that essential framework if you're managing, overseeing, or auditing AI.
You need this map.
You do. It helps you see where the risks pop up all along the way and where you need to put controls in place, check those controls to manage those risks. It gives you the full picture.
It definitely clarifies the landscape and where to focus attention. So, as we finish this part of our deep dive, maybe a final thought for you, our listener, to chew on.
Good.
Given how fast AI tech is evolving, how complex and, frankly, opaque these models are getting, how can organizations make sure their development practices, their security, their privacy measures, how can they ensure these things stay not just compliant today, but truly resilient and adaptable for whatever challenges and threats come next?
That's a big question and one that really needs to be top of mind for anyone working with AI right now.
Indeed. We'll definitely keep exploring these threads around AI operations in future deep dives. But until then, keep thinking critically about these powerful, complex technologies.